So here's the presentation I just finished about 4 minutes ago. If you were here at the Technology Day last year, I spoke about our ARM-based server, which was a product we had in partnership with Calxeda, which delivered very, very low power servers for the enterprise market. Back then we were on 32-bit, and this is really a continuation on the product line, now that we're looking at a 64-bit product now as well. A little get out of jail disclaimer at the start. Everything I'm about to say is a complete lie, and you cannot hold me accountable for anything that is in here. All roadmaps and so forth are subject to change, and all the rest of that legal stuff. All right, so just to kind of take you back as well, what was the kind of the key design factor we had within our Viridis products? It was really to kind of design a microserver technology to be at the forefront of low power server design. So this has been a product that's been designed from the ground up to really deal with the problems around power consumption in servers today, as that's becoming more and more of a consideration for most data center users. Of course, the next grand challenge for scientific computing as well, and within HPC, is the exascale challenge. So this is getting to an exaflop of computing capability. And to give you an idea of what sort of an amount of power you'd need to use today. So today, the most of the large HPC clusters might do about 20 megawatts or so of power, which have a running cost of roughly about 1 million per megawatt. If we were to put together an exascale system, we'd need somewhere in the region of almost 1,000 megawatts to run, which would cost almost $1 billion a year to run. So power at this sort of scale is a very, very serious challenge and problem, and this is one of the key design criteria that we took into consideration when developing these platforms. So what we've kind of done to address this is having an all-in-one system on chip, so eliminating the modular component design, and again, trying to address density and scalability, as well as very, very low power and density optimized designs as well. Just a couple of snapshots really from some of the media coverage we had on this product over the last year or so. We won various different awards. The Green IT logo is inside there. Linux format mentioned that we were a significant power advantage over x86. Extreme Tech considered us a serious threat to the x86 server domination, and we also got a CRN, one of the 10 coolest servers of the year also. So it's been very, very well received in the industry so far. And just as a little recap as well on where we have been over the last while. So if we went back about 2 years ago, we launched our very first 32-bit ARM system. And this was using the same CPUs that you have in your iPhones and smartphones today. And we packaged 48 of those inside a 2U chassis. Each individual server was consuming about 5 watts of power. To put that in perspective, a standard Intel dual socket server will consume anywhere from 300 to 400 watts. So we have almost a 60x decrease in power consumption. And even over at supercomputing in November last year, we had one of these Viridis servers connected up to a generator, which was connected up to a bicycle. So we had somebody cycling a bike, which was powering up an entire OpenStack distribution on top of a number of ARM servers, just to give you an idea of how low power it is. So this was again one of the first ARM enterprise-grade systems that was available in the world. We were a global launch partner with Calxeda. We have over 50 proof-of-concept customers out there today that are leveraging our ARM technology in different verticals and fields to investigate some of the niche use cases for it. And now moving forward, we're going to integrate multiple architectures with multiple vendors, and making sure that we're kind of developing the market and not just backing an individual player like Calxeda. So for those of you who kind of aren't aware, Calxeda were one of the very first companies to bring in very high density ARM-based platforms to the server space, but they folded a number of months ago, and we're now working with other partners again to move sort of towards 64-bit, and Viridis as a brand is going to encapsulate all of these ARM products. If people are interested as well, we've actually got a blog called LowPowerServers. On this blog, we've done an amount of benchmarking and results and just general reporting on where the ARM technology and products have been successful. And if people are interested as well in testing out ARM systems themselves, We also have an ARM cloud which provides people with a facility to migrate their software from a traditional x86 platform over onto the ARM architecture. A couple of existing customer reports we have. So this was a white paper that we did with the University of Luxembourg and the Poznan Supercomputing Center. So they took our platform, they measured how much power it took to complete an application. So we weren't measuring the execution time, our time to result didn't matter, we just measured the overall power consumed from start to finish of a number of different applications. And you can see on the chart behind me we use kind of traditional HPC benchmarks for this. Now the most interesting result of this was that across the board our platform consumed the least amount of energy across all of these applications, even though the runtime might have been slightly sort of longer. So ahead of the Intels, even Atoms and AMD products, if you were just worried about the amount of power consumed to complete an application, ARM demonstrated itself as being the most power efficient platform available on the market to do this. So if you can leverage performance improvements and increases through parallelization and running multiple jobs concurrently, you can actually scale up your ARM systems to achieve much, much greater performance per watt than you would on traditional architectures. There's another fairly large project in Manchester, which is Spinnaker, and this is a very massively parallel computer architecture inspired by the fundamental structure of the human brain. So the very, very long and short of it is they're putting together a system that will hopefully scale up to around 1 billion cores, and this is going to be used to simulate the neural connectivity of the brain. Now they're designing their own ARM architecture with ARM themselves, but they're using our Viridis platform around the edge of this network for job submission and workload compilation and workflow, so that the entire architecture is ARM throughout. With Cancer Research UK and Eurocloud, we also engaged with them in a project where we mapped a load of biomedical applications over onto low-power SoC environment. So we took 2 racks of their existing, I think it was 3 or 4-year-old Intel servers. We implemented a storage solution based on Ceph, LampStack, workflow agent, and we ported all of their workflow over onto 48 of our servers. They actually did a presentation at ISC last year where they presented all of the results. And again, across the board on a number of biomedical genome sequencing type applications, they demonstrated that the porting was a very, very straightforward effort and didn't consume an awful lot of time. And once the applications were actually running, the performance per watt advantages running on ARM were quite significant in the field of biomedical HPC. So that's another very interesting case study we have. Also, I'm working with KB and the CentOS team in porting over CentOS over onto ARM, and this is specifically on A15 as well. So they're actually using our ARM as a service cloud at the moment to do a lot of development and rebuilding of packages for the CentOS distribution, which I know a lot of people end up using in the cloud space and in the HPC space. So it's a big product to have on board and a great company to be kind of working with. So if we kind of have a quick look back over our lineup and roadmap for the year, as I said, we were one of the companies to have launched the world's very first ARM systems. Back towards the end of last year, we released our A15 product, which it was still 32-bit, but we introduced up to 16 gigs of RAM and added virtualization support to our ARM platform. And this made it a lot more applicable for cloud environments. So people that were using Citrix and Zen, we actually did some of the Zen and Citrix huddles where we actually demonstrated their product running on top of ARM. So we were able to leverage some cloud platforms using ARM servers now. So if somebody wanted a couple of LAMP stacks out in the cloud, they could just bring them up on an ARM server, and the end user wouldn't even actually know unless they were digging around in proc CPU info or dmessage within the Linux kernel. Later on this year, we hope to, or no, this last month actually, we launched our 64-bit platform, and this is quite a significant movement because again, it's one of the world's first 64-bit ARM platforms to be released into the market. We've partnered with APM on this, and this has been one of the constant feedbacks we've had from the general HPC user space. The 64-bit processing for double precision floating point is pretty critical for a vast amount of HPC workloads. So while 32-bit still has its niche in place within kind of storage and potentially streaming of services and video, we really did need 64-bit to really grab the wider HPC market. So we launched our POC, one new product last month or last week even. It was just at ISC, we had it in our demo room. And later on this year we hope to have larger, higher density microserver 64-bit platforms, as well as potentially an open compute platform towards the end of the year. Now on top of this as well, we've also been working with a company who are looking at bringing MIPS technology back to the market as well. So this is something that we're also working on underneath our Viridis umbrella, which could have a significant impact on the low power computing space as well, but it's still very early days with that. We have got remote access under NDA to some of these platforms if people are interested. So our current A15 based system, I mean, you can see a picture there of one of the actual sleds. The specs are 48 of these low power servers within a 2U chassis. Each sled has about 4 servers on there. And if we look at the kind of performance gains we have over the previous generation, this is the first of the ARM chips that has really been designed from the ground up for the enterprise. So really with the A9 we were retrofitting a mobile technology into the server space. This is a technology that has really been designed from the ground up with enhanced memory controllers, with enhanced memory bandwidth and enhanced floating point performance for scientific workloads, and a larger amount of RAM, so you get 4 gigs of RAM per core, which is it's a much more familiar sort of setup to what people are using on Intel's systems today. So that's still shipping today. It's still very, very applicable for a wide variety of workloads, and again, very, very high density, very, very low power. This was the platform that we announced at ISC there last week. So we have, again, 64-bit, 8-core ARM 64-bit platform. We can optionally add in NVIDIA GPUs. The guys at Mellanox, they have all of their InfiniBand and Ethernet drivers already ported over onto ARM. The CUDA drivers and environment are always already ported over onto ARM 64-bit as well. Fedora and Ubuntu, they're all available out of the box. We've got 40-odd thousand packages ported and ready to use in those Linux repositories and distributions, and it was one of the world's first ARM and Tesla GPU systems actually shown and demonstrated. We're also going to have a product which will offer a very, very low power storage platform with our friends over at Ablecom. And this allows us to combine the low power ARM CPU with very, very high density storage capacities and environments. So this could be a really, really interesting product for people that are looking at scale out storage solutions that want a very, very low power, low cost storage server. And we've tested this in-house with technologies like Ceph, Hadoop and Red Hat Storage and Gluster and all these guys as well. So it's ideal for that sort of area. You've probably seen it already since I'm nearly the last presentation of the day, but it's inside in the demo area if you fancied a quick look at it as well. Block layout of our actual system as well. So you can see there we've added in high-speed memory controllers to speed up the memory bandwidth of the actual ARM system itself. The 8 cores run at 2.4 gigahertz, so they're very, very capable at most workloads that are thrown at it today. You can see there's 4 10 gig links coming in and out of there as well, which are allowing us to actually develop very high density, very highly scalable base systems with a very, very high amount of bandwidth between nodes, which is very, very critical for large parallel workloads. With this migration to 64-bit, while 32-bit is still applicable in a lot of streaming and cold storage and sort of static front-end web servicing, with the addition of 64-bit to our product range, we now widen up our sort of use case application into a lot more data-intensive and compute-intensive environments. Okay, the main reason behind this, of course, is TCO. So a lot of considerations for data centers are now being driven by both server cost and power. It's no longer just a problem, the actual server cost. The running costs over 3 years play as large a consideration in server procurement today as well. And from research that we've done with APM, we can see that between server cost and power, that's over 90% of the TCO in the data center. So being able to reduce that has a significant impact on the actual server space, and we really do need more power efficient platforms to facilitate the expansion of large new data centers for both cloud and HPC. And we need a viable alternative to x86 as well. Intel have had it a bit easy over the last while. This is some benchmarking results that we have from the HPCG benchmark. This, even though the ARM graph is slightly lower, you can still see that we're getting very, very close to where x86 is today with a GPU included. Now what I didn't show on the graph is that the ARM platform is somewhere in the region of about half of the actual power consumption of the x86 one. So we're getting very, very close to the same performance, but with half of the amount of power, as the ARM system is really just in there as a host for the K20, and the difference there is just the difference between the CPU architecture. So the more GPU intensive your application is, this is actually a really, really good low power host to compare against it. The benchmark was just recompiled. It was a very, very straightforward remake and configure using GCC as a compiler. Very easy migration, and the TCO benefits were obvious from it. I guarantee if we spent a bit more time optimizing the ARM build of this, we'd probably get it up to a sort of a neck-and-neck line with x86. The ecosystem is ready as well, so there's been a huge amount of work put in to ensuring that the ARM hardware itself has all of the familiar software and environment that people are used to working with. Oracle have announced support for Java. Red Hat have demonstrated Rel 7 running on ARM 64-bit. At ISC 2 weeks ago, we demonstrated Hadoop and other enterprise applications running on this platform inside an R&DA room, and Canonical have also demonstrated Ubuntu 14.04, which is the long-term release of their product running OpenStack, again with tons of packages in their repositories. So this is a platform that's ready for the enterprise and has all of those familiar ecosystem pieces of software that people are used to using day in, day out on their standard x86 stuff. So just some of the highlights again, there is a demand for an alternative to x86. Power and capital costs are a serious challenge for HPC. Our SoC architecture, we've about an 18-month lead, we believe, on most of the competition out there. We're going to be the world's first ARM 64-bit server, optimized for cloud and HPC. We're going to enable a 50 to 70% TCO reduction. The ecosystem is ready, and I think we've got significant differentiated advantages over other ARM-based solutions as well. So that's kind of the ARM side of it in a nutshell. I'm going to speak very, very briefly about MIPS also. So MIPS was a technology that was bought out by a company in the UK called Imagination. It's been around for over 30 years at this stage. Again, it's up there with the kind of industry-leading, low-power, highly efficient CPU architectures. They've actually shipped more than 3 billion units worldwide, but you'll often see them in your TVs and skyboxes and routers at home in your actual house. So they typically have MIPS CPU control processing units in the sort of digital TVs and Wi-Fi routers around the house. They've also been at 64-bit for over 20 years, and with that they have a very, very mature software-based ecosystem. And again, we've got some development boxes in-house that we can enable remote access to. They're no stranger to the HPC space. So if you track back to November 1998 and had a look at the top 500 list, more than 20% of that list was actually based on the MIPS architecture. So it's proven itself at the very highest end of the computing spectrum, with over 100 systems in that top 500 list previously running MIPS. So it just really needs it's a proven, mature technology that's undergoing a reboot at the moment and could have a significant impact on this space in the not too distant future. The guys at Imagination have also launched this Project Purple, which is an open source foundation, and it's kind of geared towards supporting people developing stuff from the device right through to the data center. So having a consistent architecture from your mobile to the cloud and not having to re-port stuff in and around like that, that is one of the main reasons behind setting it up. They've got some very, very big companies behind them. And again, they'll be contributing substantial open source resources to this to ensure that people have the resources and support that they need when it comes to writing software and porting applications over onto MIPS. Okay, so I think I mentioned this in my last slide as well. Everything that I've spoken about here today, there is remote access and testing facilities available to anyone that's interested in investigating these a little bit further. So thank you for your time again, and yep, that's the last of it.
Thank you very much again, David.